Our project is a European project, so it's funded by the European Commission. Its goal is to develop safer mechanisms for robots to travel around pedestrians. It also aims to ensure the safety of pedestrians and to improve the control system.
The robot Quolo is a device developed first at the University of Tsukuba in Japan. It can achieve the sit-to-stand transition through a passive mechanism. What we implemented are these LiDAR sensors, one in the front and one in the back of the robot, because we have a person right in the middle, so we need to have a 360-degree view of what is happening. We have also a focus attention area, which is where the robot is driving towards, so that's a camera. Beside these two sensors, we also have a bumper around the robot. We have the robot algorithms developed here at the lab, and usually that was done in simulation. We use accurate or some estimations of how the people around the robot moves. But in reality, when you go outside, people will move and behave in unexpected ways. Today we are doing the experiment here at the city market of Lausanne, where we are trying to drive the robot from one point to another. And Quolo is in a mode that is called semi-autonomous driving, where the person on the robot directs in which direction the robot is moving, and the semi-autonomous driving controls how to avoid the people around and recognize all the people in the surrounding. People around the robot sometimes don't even notice that there is a robot, so they drive and walk normally around it. So this is very good for our experiments because people behave normally, and then we can gather good data about the behavior of the algorithms when they are avoiding the people and if they work well together. And for second, we are still evaluating how well does the low-level algorithms for controlling and avoiding obstacles works when the person is driving the robot. To be able to understand what's the result of a collision, if it will generate an injury or not, we are collaborating with a partner institution in Bern that do crash testing. The probability of injuries, of course, varies, and we have probabilities very low, 5 to 10% or 10 to 20%. But there is certain probability of a serious injury.
Now that we have an estimate of the risk at contact with the pedestrian, we need to develop a control system that will mitigate those risks. And there are two ways to do that. One is to, of course, reduce the velocity as much as we can. Second is to absorb as much as possible all of the impact onto the robot. We can do that mechanically, we can do that in control. In terms of legislation, our next step is really to document, which we've already done, and to really get the world around so that legislators can have data and they can start thinking about what would the regulation look like.